think he was looking at you. He's preparing to say something else. If I don't like you.
I don't know what he did there. Okay, this is thymus gland here, and I'm going into the pericardial sac. I'm busy damaging it because I need to see what's what. Now, whenever you're looking at an organism and you have internal organs and body wall, remember the surface is called peritoneum. That's a sheet of cells, and actually in here the latex seems to have gotten between the peritoneum and the muscle, and it was just a mess. Now there are two categories of peritoneum, visceral and parietal. Viscera is guts. So the peritoneum on the surface of the guts is visceral peritoneum, and the peritoneum on the surface of the cavity is parietal. When you get to things like the heart and the pericardial cavity, it's called parietal pericardium and visceral pericardium. The visceral pericardium is the surface of the heart. Parietal is this membrane that surrounds it. So if you just keep parietal and visceral, visceral is easy to remember because that means guts. That's going to be on the organ, whatever it is. Parietal is surrounding. It's part of the chamber. And again, a lot of that surface, I think, and fluid-filled space has to do with reducing friction between organs and body wall, that the organs are free to move and they're not dragging against or pulling the body wall with them. You'll recall that organs don't just fall out, they're suspended in mesentery. I've ripped a lot of mesentery here, but even within the intestine, there's mesentery connecting one part to another. And if you think of, well, why is that? Remember, when the organism formed, the digestive tube was straight, and there was mesentery suspending it dorsally. And as that tube gets more and more complicated, the mesentery just kind of gets bigger and bigger and bends with it. So that original straight mesentery gets all crinkled as the intestine folds. Getting up here to the heart. Now let's see. I think I can snip through these little teeny vessels because I have no idea what they are offhand. Right through that. Oh, there's some nerves there too. I'm going through everything because I want to find the major vessels here. All right. Ooh, there's a dorsal aorta. See that? And it's coming right up here into this and making a loop right here. So what would you call this part that turns around, the aortic arch? Yeah. Is that part of pulmonary or systemic circulation? Systemic, indeed. And now from the arch, okay, dorsal aorta is going to carry blood posteriorly. Actually, that's not such a bad dorsal aorta now that I've seen it. It's got to have branches anteriorly also. Now, what I'm going to do, let me just grab another tool in here. Excuse me. I seldom use this, but these are handy for cutting bone. And I'd like to just kind of open this up a little more, so I'll snip out the rib ends. That's pretty good. We'll see what the aorta is up to here. Okay. Some more thymus out of the way there. Aortic arch, expose that. Okay. So here's a short little trunk that gives a branch to the left and to the right, and off the right side, yeah, where is it? I want to see, there should be a branch into the right arm, shouldn't there? You may find it better than I do. That seems to be going into the thymus, so I'm going to discount that. I want to write subclavian somewhere here. Aha, ha, 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 ha. There it goes. Right there. So this is brachiocephalic trunk, There's the left common carotid, called common because it's going to branch into external and internal. Here's the right common carotid, and just as in the pig, the right side gives rise to the right subclavian. Where does the left subclavian come from?
On the brachiocephalic.
From the arch, actually. And what do you know? There it is, coming off on its own, just like it did in the pig. So we have the aortic arch, brachiocephalic trunk, left and right common carotid. A branch off the right is the right subclavian, and a branch from the aortic arch is the left subclavian. And then the arch turns around to become the dorsal aorta. Now, what about pulmonary circulation? I have this big other thing right in front there. What do you suppose that is? Yeah, pulmonary aorta. And let's see, it's coming from, if we trace it like this, it maybe is coming from the right side, and this big thing going straight down is coming from the left side. We could open up the heart, and maybe I should, but remember, it's all injected with latex, so that can make a mess out of what I'm going to see. Now, blood coming into the heart, excuse me, is coming in on the right side. Oh, yes. So here's a big old posterior vena cava coming in, and I'd like to have an anterior vena cava. Yep, there it is, bringing blood back from the head, bringing blood back from the body and from the liver into the right atrium and auricle, which are here. As you'll recall, hepatic portal is bringing blood to the liver, and if we get lucky in here, it's in here somewhere. The bile duct is in here also. That's probably hepatic portal right there. And this looks like the hepatic artery coming off the aorta and going to the liver. Hepatic portal is taking the nutrients into the liver. Liver is operating on them, and then it has a very short connection into posterior vena cava. Maybe I can see it if I cut some more through the diaphragm. Yeah, just sort of. Well, hard to see. Here comes posterior vena cava, and hiding in this connective tissue, I broke it, is the hepatic vein. Hepatic portal vein from intestine to liver, hepatic vein from liver into posterior vena cava. Got that? So go forth and